Okay, good morning, everyone. Very welcome to third week. Today, we are going to officially start the object-oriented. It's gonna be really helpful if you guys keep paying attention about how I define it from the beginning, especially anyone who already finished the previous example with me last week. I haven't had the chance to post it, although it probably works tomorrow. By the end of the day, I post this recording and the previous one, which was for how to create a box. And now we are gradually going to learn how to split the file into different sections. So I'm gonna start sharing my screen and just go through the basic of object-oriented with you. So, recommendation, as always, please go ahead. Make sure your Visual Studio is open. Still, I notice okay, probably I was muted, therefore I'm gonna just I was muted for the recording. I'm gonna just quickly explain it again. I'm trying to start the object-oriented definition today, and I'm gonna start with defining a brand new project under console app. So I use console app C++. Of course, you can use empty file also, but since console app, it has like template on it, it's much easier for beginner to use the template. Otherwise, you can use an empty project. Look at, you can see right in here, I do have another option, which is empty project C++, okay? Just the same. The only thing in here, I do have a little bit of template that makes it easier for beginners to follow. Still, you need some little adjustment. About where to save, just hit the three dots. Make sure that your OneDrive is already active and store everything under your OneDrive to make sure this is accessible to you from any other location if you're out of the classroom, or if you want to just continue working on the same program using your personal devices at home. So give it a few minutes to just create the template for you. Meanwhile, I'm gonna take you to the lecture slide. We are in week 3 under the module for the introduction to OOP, stand for object oriented programming. You probably notice I have two of them, OOP 2 and OOP 1, because this lecture is a little longer. I teach it in 2 different weeks to make sure everybody to make sure everybody becomes familiar enough and practice enough how to create different project under object-oriented. So before I start the lecture, you can see what it is available to you right in here. I'm having one lecture slide, which is the main one I'm gonna use right now. It's a shorter version because I'm gonna quickly go through it and spend more time on the actual programming and explain everything right in there. There are students, they need more of written version of whatever I'm explaining verbally. So anyway, I'm completely explaining everything from scratch. But there is another version that I have posted right in here. This one is more of my verbal explanation, but it's still exactly same content, okay? Nothing extra, but a little bit more explanation in written format. Even the examples I'm having in this one is exactly the same as the one in a shorter version. So shorter version is a quick one for those who just wanted to quickly review and then move to the programming. But still, if you want maybe a little bit of what it is explained under your reference book, this is a copy of the reference book in here. So you can come back and you can go through it on your own time just to review, or simply just watch my recording. Either will work. So have any of those kind of maybe students who are behind? If so, feel free to let me know. Thus, you didn't do, why? You were absent? You didn't do it on your own? So if you quickly go through the slides, even if you're absent, you can see what's going on. And as I just show you, always under avenue, under resources, you can see, for example, this one example for lecture 3. Even for lecture 2, structured data, under notes are my lecture slide. Under resources are my solution to the in-class example. This is going to be your 100% responsibility to go there, look at them. If any part of it is not clear for you, reach out either during the class time, or the best way is either under the video I'm going to post for you on YouTube, drop your question, either myself or someone else will answer you, or another method. See how many method I left for you. We have in here discussion post. You can simply come here. I taught you how. Just create a discussion post, ask your question. Myself, other students in the class, TA, everybody has access to the discussion post. Anyone who can see it faster than others, then they will respond you right in here. But do not stay behind. Do not create any excuses to not to practice. Object-oriented programming is heavier than basic C++ programming. If you stay behind, if you lag, it's going to be like that for the rest of the semester. And then at the midterm time, final exam time, then you are not going to stay happy. That's not my intention, right? My intention is everybody could learn, everybody could actually enjoy the class and grow and live happily. But that's what I can do. The rest is on you. So let's start with introduction to object-oriented programming. If I'm going to just summarize it just shortly for you, we do have two types of programming. I would say computer programming in general. Of course, if some of you have some understanding about C or Python, other languages which are closer to C++, I want you to understand this object-oriented programming is available only on C++, not, for example, on C, because C is a procedural programming. It doesn't have the capability to be split into multiple files. C++ has more syntaxes, more keywords, and of course, a bit more complicated than C. Although some may think that C is complicated. C is easier in order to use it to communicate with hardware, which we call it embedded system. But C++ is more of only software programming. It's not something easy to use it for hardware programming. Why is that? Again, because C++ has a lot of features, a lot of keywords, a lot of syntaxes. It's not understandable for most of the hardware setups. And of course, if I'm going to push it to one microcontroller, for example, and then is finally applicable for that certain microcontroller, then later I'm going to use another microcontroller, I have to change it. I have to apply a lot of changes. That's why we use C in order to communicate with hardware later in upper years. Some of you are automotive engineering students, some of you automation. Regardless, at some point, you have to interact with some hardware. You have to be able to program some sensors, right? Or some electrical devices in order to just do some automated application for you. Therefore, I want you to understand procedural programming, as I have right in here mentioned it, is a type of programming which has a focus on a step-by-step programming, right? Very similar to C and very similar to what we've done so far. In C++, which is the basic programming, we did procedural. Of course, week 1, week 2 in object-oriented course, also we still did procedural programming. That's why I always had only one .cpp file for you, and I was defining all the functions, all the information that I need as a procedure to complete. For example, the box that we did it last week. I created a box which had random sizes, 300 box. Remember, we created 300 random box with random height, with length. But we did all of those step by step as a procedure under the same .cpp file. Now, what I'm going to just teach you right now in here is now object-oriented. Means, remember, I always told you, if you're going to create different function, always try to add them underneath your main function. And inside each of those functions, we're supposed to define a step such as all the equations we need for calculation of, let's say if we are going to calculate volume, or we are going to calculate area, or whatever mathematical expression that we are going to use. So means any method in order to create an object, regardless of what that object it is. Any method we use is going to be considered as the, let's say, implementation of a file or a project. If I'm going to go back to the box, for the box, who can remember, after I've created those random boxes, what was the very last step of the program? The very last function that I used a structure in order to create it. Yes. Pardon? No, the box structure. What was it? Not the actual structure, the one that I used box as data type in order to define the function. I'm supposed to calculate greatest area, right? Can you remember that? I calculated the greatest area for the box. Which box has the greatest size? But now what I'm going to explain in here is all of those methods, in order to calculate that, for example, area, supposed to go through a different procedure. Same equation, same mathematical expression. But in order to make it object-oriented, I have to put it underneath another file. So I have to define extra.cpp and extra header file, right? So that's what we call it object-oriented. There are limitations with procedural programming, right? That's why we decide to create object-oriented. Those limitations is, generally, if I put down anything, let me just bring up the same example that I solved for you last week to just first not only remind you what was the example, also show you, although this is still in learning environment, it's not that much complicated, but look at here. This is the problem in lecture 2, the one that I say, hey, we are going to create a structure box. This is my struct. I define my length, width, height. And then later, look at here how many extra functions I define. One for example, getting the random side, right? I wanted to just consider 300 random box. So I needed to get the side, and then I needed to figure out how do I create those random boxes. Look at how lengthy is this code. And then I created another one as conditional box. And then I was using input-output file, external communication. Means do all the calculations and everything, and then export them to a text file. Later I ask under another function, now you have the text file, go get it. Read the information right in here as an input and apply a little bit more changes because I want the surface area. And then when I calculated all the surface area, I said now find out which surface area is the greatest. See how lengthy it is. Now, suppose in real application, this one is only 3 pages. If I put it inside the Word document, and I'm having 4 or 5 functions in here, there are situations you might have hundreds of functions. Therefore, if you do like procedural, going back to here, if you are using procedural programming, one of the limitation is it's going to be difficult to troubleshoot, if anything, or it's going to be difficult to adjust them for different application when everything is under the same file and lengthy. Another one is it is easy to break. In case the file is broken for any reason, we are going to lose everything. But if you split the file into multiple smaller sections, even if one of them is broken, at least the other could still be used, and we can only compensate for the last one. So it's much easier to split it to multiple files. And then if you want to just link those files together to exchange information, it's much easier. If we have like trouble and we are going to troubleshoot, it's much easier because it's a smaller file. We can see everything much easier. So all of those are the reason that we are moving from, after some time, when our students are confident enough in order to practice procedural, then it's time to learn a little bit more advanced version of programming. So far, so good, kids. Some just join us. Very welcome to the class. We are looking at definition of object-oriented. Log into Avenue quickly. Stay with me and make sure that you have good understanding of previous example. Otherwise, it's going to be a little bit challenging for you to follow. So it's time to just start practicing what I'm going to tell you on Visual Studio. So I'm going to clean up my screen since I'm using a template. And I just leave only whatever necessary in here. Expectation, everybody at this point knows what are the essential steps. So I'm going to just add, what would I add in here? Using namespace. Namespace, std, semicolon. You may want to add return 0 still as a part of, or maybe even system pause. If you want very complete template for yourself, system pause, return 0, they could be also included inside your template. Now, let's go back and see what are the new information that we are going to practice. None of today's information is something that you heard it in maybe other classes, other lectures, or previous semester. This is all new, therefore pay attention. Last week, I taught a struct. I just show it right in here. When I'm gonna define a new function for myself, I can use the keyword struct. This is exactly what I said last week. Struct, and then do I need any certain header file? No, it's just under iOS stream. And then I pick a name, whatever the name, and then I define my structure members. It is no limitation. I can have as many as needed. And then later box becomes a data type, right? In this example, it could be any other variable in other example. And I can look at here, at the end of this code, I added another function and I used box as a data type. Now it is known because I defined it manually. Somehow I created my customized data type. Now, today in here, like what we did for a struct, and we turned that structure to become a known data type for our compiler, we are going to use another keyword, call it class. What does it mean when I say class? Class has a little bit of difference with a struct. Of course, still, the way that under a struct, I had like freedom to define different structure. Remember, for class, I do have freedom also. Class is a keyword again. I have freedom to define multiple class member. In here, I call it class member. In there, I call it a structure member. So I can create object also, and those objects are instance of class. What does it mean? Means those are somehow a family member for that class. Means those object doesn't mean anything without that class. I'm gonna use this very simple example right in here for you. Suppose that you are building a house. What do you have in this house? The actual house that you can see in this picture. This is going to be my class name. Suppose I'm creating a class and I'm calling it house. What are the class members right now? Anything included in this house? Like what? Like this windows, like this door, these steps, the walls, the roof. These are what we call it class member. Make sense? So I create a class, I call it house, and then anything which is creating that house means object. Those objects are a member of that certain class. Like this windows alone doesn't mean anything. This door alone doesn't mean anything. This step alone doesn't mean anything. But they are all together creating this house. Make sense? Now, another example. You guys are coming from a family. Everybody has a family. You have one common name, which is your last name for the family, right? Myself, I have a last name, and that last name is a common name for everybody in our family. My siblings, my dad, we all have a last name, which is similar for all of us. But we do all have, in addition to that first name, those family name is the class. And those first name are the member of this class, right? Your siblings are a member of the class. Your parents are the actual class. Make sense? Your dad is the actual class. You guys, under that class, under that family with different first name, you are the member of that class. Now make sense? And that's what we call it object-oriented. Means we are going to create something, and in order to create that main something or that main object, we have some minor objects under that category. Generally, in terms of theory, makes sense so far? Yes or no? So now, if you have that good understanding, now it's time to look at how do we do that. Just stay with me, and we are going to create one example. I'm going to first show you a complete example with creating a class. Look at here, and then I'll do it under here step by step. So how do I define class? Look at here, I have my main. Where is my main? Main is here. My class is something that, again, very similar to a structure. I created out of main. Make sense so far? Very similar to what I did in a structure. A structure is not initially defined inside main, it's out of main. So now let's go and create the first class together. So I'm gonna push my main down because I'm not creating it inside. I have to create it outside. And I'm gonna step by step tell you what's the keywords. Use class. Immediately it turns to blue. Means this is known for the compiler. And then I give it a name. Name could be whatever. I'm gonna say just name. It's a variable, right? It could be anything. I'm gonna say name. Name is the class name. And then it's mandatory, very similar to a structure, to open and close curly bracket, and at the end of curly bracket, finish it up with semicolon. For any other function, we do not add semicolon, remember? But for a structure and class, it's mandatory to have a semicolon. Good morning. Do you want to wash your face? You are taking a nap from the beginning of the class. If you want to leave and come back, I'm okay with that. Just drink some water or maybe. Okay. So now I'm having the class, call it name, right? So now it's time in order to define, I'm going to leave you a message in here. This is the class members. What are my class members? Because we can have two different type of class member. We call them private and public. Follow me. For the rest of the semester, we keep repeating this stuff and we keep using them. You learn it one time and then comfortably just use it. First category is going to be private. So anything I put in here is going to be class members. As soon as I type private, it turns blue again. And then it's mandatory to add colon. Simply means private is a keyword. Make sense so far? Stay still with me. Right after that, I have another group of class member called public. Again, I type public. I add colon, not semicolon, colon. Make sure inside is colon, not semicolon. Do not go wrong with this. Okay? And I see both of them are turned to blue. Simply means both of them are known for compiler. I do not need to define these two keywords. These are not variable. So far, so good? Now, what is private? Private is a type of, this is important. Private is a type of class member which is available only inside this class. Very similar to local variables and function. Remember I told you local variables are those we define them either inside main or inside any extra function, and they are only available inside that certain function. How about global variable? Global variable, instead of defining them, suppose inside main, we define them out of main, and they are reusable without any need to redefine them. You can keep using them in any extra function over and over. Now, similar concept, but different application. In here, I do have some certain type of member variable which are only available inside this class, which I called it name. And there are some other parts right in here which I can use them in other classes. Now make sense? So let's put down some example. For every member, definitely I need data type. Suppose I'm going to use double. You can use any. There is no limitation, right? It's not like, for example, only certain data type could be used. And then again, let's give it like another variable. So I'm going to say, since this is name, I use the class name. I'm going to say double a student ID. You can do anything. And then close it with semicolon. SID, student ID. I can use another one, double student grade. Remember, at the end of private, I use colon. At the end of the members, like very regular variable definition, I use semicolon. Do not confuse them. So now, whatever I have, a student ID and a student GR standing for grade, for just making it simple, for the sake of time, these two are only available inside the class name. Now I'm going to start defining some public. Remember again, public means if I define anything right underneath in here, it's going to be accessible. Public is a kind of function, right? So it's accessible inside any other function or like outside of the class, I would say, to be general. Outside of this class, anything I put down in here is going to be accessible. I can use them in order to either address the same information or even adjust them because they are public. I can adjust them outside of the class. Let me just use some example. Again, remember I said it's like function. Therefore, for example, I can use void. Of course, you can use integer, you can use char, you can use double based on whatever problem you're trying to program. I'm going to say void. And then since I said SID for a student ID, I'm going to say set. So far, set is a keyword, but I can say set SID. Set SID. What was my SID? SID was double. So therefore, this is going to be a double, and I close it with semicolon. You got it? So far, so good. Now, you can see set SID is underlined green. That doesn't mean this one is wrong. That simply means still there are other steps that I have to go through them because it's not complete. And I have to complete it in the maybe next step. If something is wrong, it becomes underlined wrong, red. But since it is green, means there are other steps that I have to add later. Okay? So next, I'm going to use another one for, I'm going to again say white, and then again set, because I have two variables, set my SGR. Remember what I use for that means student grade. And then I'm going to say, okay, this one is also, remember you have to always include the initial data type inside the parentheses. How can I help you? I'll tell you. Set is a keyword which is going to get this information like a student ID from in here and set it to a certain other requirement. That's why we say set it. But at some point, I'm going to just, if you bear with me, I'm going to say first go get it and then bring it here to set it to something. So it means I already defined this variable. I'm going to write now in here, go get that variable. The variable is double. I must use double. And then I say, now go get it. Get that SID. And then in here, I say, set it to something else. Now make sense? So I get it, and then I set it to something else. Get it as a constant. And that's it. We call them setter and getter. In the upcoming slide, I explain setter and getter in more detail, and I give them certain specific name as mutator and, bear with me, in the next slide, I'll explain it as mutator and accessor. So at this point, just learn, I've get this ID, and now I'm gonna get the student. So I would say again, double. Get, again, get is going to be a keyword, and then SGR. And then I open empty parentheses, and I turn it to constant. Kids, my gets or getters must stay as const. Okay? There are a situation that we don't need to make it constant, but look at here. They are always const, but not the setter. We get them, and then we set them to something else. So now, I already did two setter together. So I got them. But there are situations, I'm going to go a little further, and I'm going to do some calculation. I'm going to calculate the final grade. This is just a grade. And if I'm going to do the final grade, I have to define another function. Like, again, double. And I keep using double simply because I might have decimal point right in here. So I'm going to say get, this is going to be final grade. So I call it FG. And then later, I define it. What is that? FG. This is it. So whatever I have in here, they are public members. Whatever I have in here, they are private members. Private are accessible only inside the class. Publics are accessible even outside of the class because they are functions. Gradually, I'll teach you constructor to be right underneath the public. Gradually, I'll teach you destructor to be under the public, because even constructor and destructor, they are going to be functions. So everything under public is always function. So far, so good, kids. Make sense? So I'm going to minimize to show you the actual template. Keep this in mind. This is the template, the whole thing, just simple template. Hash include using namespace. Your class must be defined. Keep it in mind again before main. Not inside main, out of main. I defined it, and then I defined private and public, and now it's time to define the members, which I did. And right after that, you can go ahead, create any other function in here. Add any function in here. I always add them after main. We keep following the same rule. No technical error if it is before main, but more convenient for calling them inside the main if they are outside main. I just taught you this too. Setter and getter. Now let's go a little further. Look at here. In here, I'm defining a function using class name. So I already defined in here in a slide. My function, my class name is rectangle. And then when I define the function, then I give the same name to my function, rectangle. Me in here, I use name with purpose to give you two examples at the same time, to make you familiar with two different examples, right? So one example in here, I use rectangle as a class name, and then I created a function with the same class. Now in here, I use name, and if I want to create a function, so I'm going to create it like this. I would say void. What was the name? Name. It has to be exactly same. Like if it is lowercase, uppercase, I have to have it exactly that way. So then I have to say name, and then this is important. Since this is a class, I have to say colon, colon. So I would say name, void, name, colon, colon. And then what did I have right in here? I had, for example, this setter. And it was set a student ID double. So I can just because this is the function which I'm going to redefine it with more detail. So I'm going to use them right after that. Set SID exactly as it was. And again, parentheses. And again, double, like defining regular function. And I have to now give it a name or a variable. Since this is SID, student ID, I'm going to say just maybe, again, S. And then I have to open my bracket. I'm going to maximize to make sure you can see what I'm doing. And then I can define what is that S for me, for example. Do I need, somebody tell me, do I need semicolon in here in line 42? No, because this is now a regular function. Also, I'm using a class, but it's a regular function. Now, for example, I'm going to say, what is this S? Then I say S. I used uppercase, therefore. In here, it was SID. So I use SID is assigned to just uppercase S, and that's it. Now, if I minimize, you can see this one, no more underline green. It's been fixed automatically since the extra explanation about what do you want this set SID to be is given right in here. Make sense? Your name is Gabriel? Am I correct? What was your name? Yeah, Gabriel. So now, did you learn what is the job of set in here? So I just defined this one as set a student ID to become a function. But at this point, it was missing information. So I have to come here, define it with more detail. Okay, what is that information you want me to set this as ID to? Make sense, kids? Everyone? Still with me? Yeah? Okay. So now, it's time to review quickly. This is mandatory right in here. When you are using a function or when you are defining a function which is using a class, colon, colon is mandatory. We did not have colon, colon for regular function, but we do have colon, colon when the function is extra definition of a class member. That's one thing. And then you have to define what is that one. This part is very similar to regular function. So you can even in here see a member function that stores a value in private member variable. What is private member variable? SID. You can just read my note in here and just try to understand it in the example. That one is a mutator. Means it is going to change the information. It was initially SID, now I'm changing it to S. How about accessor? Accessor is all of these getters. I'm gonna leave it in here. So anything with set, I leave in here maybe. Set or setter, I would say, is called mutator. I will ask this theory question during your final project presentation. Therefore, it is important to learn how to explain this information, right? So, set or setter is called mutator. What is the mutator? Mutator is, as I mentioned in here, is a member function. It's a member function which is storing the information of this private member, and it will set it to something else, or it will change it in some other way. How about this part? These parts, these are my get or getter. Get or getter in here is called accessor. I'm gonna minimize. So these are my, I use get, then we call it getter, which is called accessor. Accessor, again, it is a member function, but accessor is a concept. This one means you are going to just keep the same information. You don't change any information anymore. You change just in here. You don't change anymore. You just receive it from here and you just display it as a constant. Make sense? So in here you go, set that member to some certain information. In here, you get access to it. You read it and you display it as a constant. Now, if I'm going to get rid of all this under green line, therefore I have to go ahead, define very similar functions for every single one of this, and then they will be fixed. For example, I did set SID. Now, if I do set SGR, then this one will be defined and there is no more green underline. Make sense so far? So, I'm going to have your attention for a few minutes here on the slide, and then I'll give you a few minutes of break, and then in second half of the class, I'll go through a complete step-by-step example from the beginning, how to start defining a class, how to define every single required function, and how to call them inside the main, okay? So stay with me right in here, although I already explained most of them, but quickly we can review, then I'll give you a break. So kids, again, anytime that I'm going to create a class, I need private and public. Public always is necessary. This keyword is always necessary. I have to mention in here public, but I'm having an option to not to type the private, because anything which is not under public by default is considered private. That's something that you may need to know. It's not mandatory to type private, but it is mandatory to type public. Make sense? But usually I get a student to do it because it is somehow helping you to organize your program in a better way. So next, can I use pointer in order to define my class? Yes, we are going to use pointer in order to, for example, in this example in here, I use rectangle to be my class. I can later turn the class to become a pointer right in here. Rectangle could be a pointer. Rectangle, pointer, RPTR. For me is name. Can I turn this to become a pointer? Yes. I can say name asterisk for turning it to a pointer and give it a pointer name, for example, PTR, and then it becomes a pointer. The object becomes a pointer. Another extra information before leaving here. Can I borrow space from memory in order to complete a class, especially in situation that I'm defining a class which I have no idea how much space do I need to store it or to process it? Yes. How do I do it? Again, quick review. Using the keyword new. Using the keyword new, as I shown in here, you can just dynamically allocate some memory, or in here, allocate an object. So you can also use not only pointer, you can use keyword new and turn it to dynamically allocate memory. And of course, you have to delete it later. Another quick review. So suppose this blue square in here is going to be your class. I'm going to call it rectangle. Rectangle has widths, has height. Widths and heights are the private member. These are what I call them private member. Widths and heights by themselves doesn't have any meaning. It could be anything, doesn't have any meaning. But when I put them on the rectangle, simply means I'm talking about the width and height of rectangle. So these are the private member. And then anything in here, being set or use get means they are public members. Set means I'm having an like existing information. I'm just setting it to something. Get means I'm outputting. Getter or accessor, I'm outputting. So this is somehow input. This is somehow output. Get width means now you do have a set. Now get it and output it as a constant. Make sense? So these are what I call them public member. These are private member. Public is accessible outside the class as a function. So that was a quick review. Another thing I want you to learn. Anytime I'm going to separate, because we are going to separate now. Remember I said we are going to separate the file to a header file, stand in here with .h. .h, which you can see it right in here, means whatever my class name is. In this example, my class name is rectangle. In this example on my Visual Studio, my class name is name. Then it becomes name.h. Name.h means the header file for this class only. Those information for this class only are not a part of standard compiler or a standard information inside the software. Those are only the one that I create. Therefore, I have to keep addressing it, rectangle.h in here, name.h in the upcoming file to get access to those information. Those are my customized header file. If you have 10 classes, you have to have 10 of this .h or header file, right? So header file is all the information. Even in here, later you may have some of the header file, which is the actual header file for this. I'm going to expand it. There is even right now a header file. But since this is the standard header file, it's right in here. Look at here. This is the header file. These are my .cpp file. Let me see if I can even make it bigger. Look at here. This one is the start, the one that I have right in here. This one is the .cpp file. But since everything is inside this .cpp file, automatically there is no header file listed down under this folder. And what we are going to do right now, we are going to split this one. And as soon as we split it, another extra file will be listed under this section of the programming. Right? So let's go back to this part. I'm going to close this. And then .cpp I already show you. And constructor and destructor. So this only a slide and then break, and then I'll continue only on Visual Studio, a step-by-step programming. So one more time, I cannot hear you. Can you be louder? Can you ask me your question louder? Which part what? This is on the side. This is a solution explorer. You do not have solution explorer? During the break, I'll come activate your solution explorer for you. So next, all I have left in here is just constructor. Today, I'm going to also talk about constructor, which is going to be a member function, kids. Constructor could be listed down underneath a public, and we use construct as a keyword for it, right? So for example, rectangle that we already created, rectangle. If I say rectangle and give it just a name, it becomes a constructor. Constructor could have like empty, like in here. Constructor could be defined as a function underneath, for example, in here. And then simply you can just have this inside to be empty. If it is empty, means a default constructor. If we have some parameter inside the argument, is a non-default constructor, which we are going to practice it shortly. I'm going to give you a break, so I pause the recording. Meanwhile, I'm here. Ask me any of your question. Then, any question? What was your concern? You found it? Okay. If you want to go for a coffee or just drink some fresh water, feel free to do so, and then we will continue. How the lab is graded? I don't think there is anything. Just ask me clear question. Those two are completely separate. If you look at your avenue, you can see you have in-class mark and you have submission mark. That's the question? Yeah. In-class mark is based on whatever you show me or the TA. And then submission mark is based on the submitted code. We'll go through it and we'll mark. In class is always during the class time. If you do not have anything during the class time or you are absent, then your submission won't be graded. Is that the case for you? You were absent? If you were absent, and that's also right in here, you can go, I clarified this 100 times. Go here and read the requirement for the course. No, you shouldn't think. You should check. No, that's what I say. Do not think classes are going to be the same. Do not think semesters. Well, hey, I do not have any responsibility to answer a student's email during the break. Do I? Yes. Okay. And then a student's email will be answered within 48 to 72. I'm not your close friend or your family member to just stay in the chat with you, and as soon as you email me immediately, maybe I'm busy with something else. You shouldn't expect your professor to email you back immediately. If there is something urgent, you have to consider inform at least 48 hours before that urgent situation. Then they will get enough time to come read, because I teach many different courses. I have a lot of other behind the scenes things. I may only check every 2 days my email. It's not like I'm sitting in here as soon as, if I can, I do. Anytime I'm free or I'm in front of computer, not teaching, still doing other things, but the email pop up and I have time, it's not interrupting the class to answer that, I'll do it. Why not? I love helping the students, but you have to have this understanding. Faculties, not only me, everybody else, we have a lot of other things. It's not like as soon as you text us, it's like I'm your mom or your dad or your sibling that immediately I have to get back to you. No, we do not have that option. It's work. It's not friendship. Yeah, I do like have a friendly communication with the student, but it's not like you are my only student. I have too many other students. So students cannot expect us to immediately respond. Daily, I see more than 400, 500 students. How can I do that? I may receive while I'm teaching, even right now, I'm teaching and then I receive many emails. But can I interrupt and answer? No, I cannot. That's why. If that's something like that, at least a week before, few days before, weekend, I do not have any responsibility even to answer email this weekend. Why would I work? Most of the time, if possible, I help students, but you have to have that understanding. If it is weekend, it's weekend for me too. Or after 5 p.m., work is over. People has personal life, right? You have to look at faculties like a normal human. They have family. They have other things to do. 8 to 5, email and expect response within 48 to 72 hours. Like, for example, I teach Monday, Tuesday, Wednesday, 8 to sometime 10 p.m. And I don't get a chance to sit in front of the computer. So you have to bear with me. Yeah, therefore that you cannot put that on me. Anyway, course requirement is right in here. You go ahead, look at the course requirement. If you were absent, your submission gets 0. That's the rule. That's the rule, and it is included. It's not a shock for a student. It's a part of the course. It's been informed from day one. That's it? Okay. I didn't get it. Very similar. Very similar. It has to be very. Sometimes I don't include everything in the screenshot. That's extra. That's not required. The student must do it themselves. But still, to support them, sometimes I put together the solution quickly, not the whole question, but I include at least a little bit of it for them. Again, those are all extra. No one else does, but I do. Like the recording. No one else records, but I record for you to support you. Yeah. Because I have two different versions of questions right in here. I have an advanced one and then I have a simpler one. One of them is just in here for you. The solution is also underneath. Another one, I'm going to just do it for you right now. It's inside the example. Everybody, please try to clean up your screen. We are going to do everyone back. Can we resume? So, since some of you may miss the box example, may I have your attention, please? I think this is going to be mandatory for everyone. Still, some kids are not back. I'm gonna just be slow in explanation. Some of the kids in here are not back, and this is mandatory for everyone to create the file. I'm gonna, instead of a box right now, create another object for you, and I'm gonna call it cylinder. Initially, I'm gonna repeat what I did last week. Therefore, I'm not starting with splitting the file. I'm starting with putting everything under .cpp, the same .cpp, and then gradually together we are gonna split it. So I'll get you to learn which part. I was waiting for you. Be quick, be quick. I'm gonna start a program and I want you to just do it with me. We'll come back. So, and then gradually I split it to separate .cpp and header file. One more time, some kids, they just came. I'm going to create another example initially under .cpp, and I'm going to call it cylinder today. Okay, so clean up your template the way I did right in here. Still keep your main. Still, you may want to keep like the class and all of those keywords. But underneath, I had for the previous example, I had some information. You may want to clean up that and just keep this. I think I'm gonna one more time share my screen to make sure that you can see this entire screen, because it's gonna be much easier for you to follow. So, like what you see right in here, this is the template. Clean up everywhere. Keep this template. And this is the solved problem. I'm going to show you to have some idea. Initially, I'm going to define everything under this same, one more time, I'm going to expand, same .cpp. So look at it. I have only one .cpp file. And I'm going to define everything under this one. We have quiz today. If you are leaving, you are missing the quiz. Okay. And then, nice. And then I'm gonna just gradually split the same file to a header file. And as you can see in here, a .cpp. That's the plan. And of course, we always need the main one that it is right in here to become a source. Let's do it. We need a little bit more time to do this. So let's see how much of it we can done, and then how much of it you can just follow the example yourself if it is not finished using my solution. So let's start with defining my class. Remember I said I'm gonna call it cylinder. Everyone do it with me. In case you have some error, let me know. I'll pause. I'll help you to make sure everyone is following. Call it cylinder. This is the class specification. I'm going to leave note in here. This will help you to understand what I'm doing. So I start with class specification. Then later I tell you what is this. A spec, or as if you want it complete, class specification. During the final project presentation, again, I'll ask you theory question like, tell me what is class specification? Or class specification should be moved to which file? .cpp file or header file? That's why I want you to pay attention to my explanation for those presentation day. These are going to be your theory question. Theory question are not coming out of blue. It's just exactly what I teach you. I don't expect you to answer any weird question which I have never shared that with you, okay? Just listen, practice, and then you are gonna be 100% okay. Class specification means when I start defining my class members, including private and public. I must give my class a name. In this example, cylinder. This is going to be my name. I'm gonna use exactly the same name. If I use lowercase, uppercase, I must keep repeating the same class name. Right after that, I'm going to define my private members, right? My private members are going to be radius. I'm going to give it double. Can I have decimal point for the cylinder radius? Yes, therefore I can just give it double. And then I'm going to say, this is my first one. And I'm going to create another one and I call it height. Again, double. It's totally up to you what names you are going to use. but I use this ones. So these are my privates. So I can just move this to right in here. Again, private, if you don't mention it, by default, compiler will consider anything out of public as private. That's the first one. Right after that, I'm going to look at the member function. Member functions are always defined under public. And I told you, public has two types of member functions. Some of them are mutator, some of them are accessor. I kept those notes in here. Therefore, I want you, when you go through even your lab and you want to comment it, comment which part is your mutator, comment which part is your accessor. Keep repeating this information until it becomes a default information in your brain. So now, I'm the mutator members, and remember, for mutator, what was the keyword? Who can tell me? Yes, set. That's correct. I always use only set. And then whatever I use right in here, radius, I'm going to say radius. And then what is next? Open your parentheses and then use the exact same data type, which was, for my case in here, double. That's it for set radius. I do the same thing for height. Again, I say wide, set, and then of course I need double again, and semicolon. I'm done with my mutators. I keep saying setters, mutator, to make sure you know both of them are the same. Setter, mutator. Now, next I'm going to look at my accessors. So far, I got the radius to be defined as private. Now, since I have no access to this private out of the class, I'm going to turn it to public as a function. So I set that radius to something out of this class later. We'll go through it. And now I'm going to, after I set it, suppose it's done setting, now I'm going to get it. How do? I use the exact same data type. What is the keyword for getter or accessor? Say it. Get. I said getter, so simply means get, right? But if I say it still, accessor means the same thing. Now I'm going to say radius. And then right after that, again, I need parentheses, but this time empty. What's the next keyword in here for getter? Const. I turn it to a constant and done. I do the same for height. I say double. I say get, and then parentheses, and then const, and done. I'm done with my accessors. Do I need more? Yes. I'm planning to have, I got my radius, I got my height, and I'm planning to calculate volume. Since I have that in my mind, to after I create my, a cylinder. At some point, I'm going to teach you a rectangle also. So since I already have that in mind, to calculate another function as a volume, I define it right in here. I say double, and I give it some name. I will use this later. And then also, since this is another accessor, I need to turn it to const. So this is going to be a member function to calculate the volume of my cylinder. Make sense so far what I did? Remember one more time, you are defining your class specification. Therefore, make sure you are not missing this semicolon. If you miss this semicolon, it's going to generate error for you. Still with me? Students in the back of the class, are you following? Did you create this one? If you do not have this one, you cannot split it and you will stay behind. So make sure you do it, you create it for your own practice. I'll come around and I'll look at your programs. You cannot split it from the one that it is inside Avenue. You have to create it yourself to be able to split it to multiple files. I'm in here and look at here. All of this, which are underlined green, simply means they are waiting for me to assign more information to all of them. I'm going to start with the first one, which is set radius. So I'll move to after my main and I start creating them. So I give it void. It was void, right? And then I must initially call my cylinder, which is my class. And then colon, colon, follow the steps. And then right after that, I'm looking at my set radius, which is this one, set radius. And remember, it was double. I continue using double, and now it's time to set it to something. Its radius, I'm going to say R. And then curly bracket. And then set the radius attribute. How? Say radius assigned to R. This is mandatory to avoid error. This is not optional. And now if I minimize, look at here, I set my radius. If I go up, there is no underline green in here. So far, so good, kids. I repeat the same thing for height. So I'll do it quickly. Void, set, height, and colon, colon is mandatory. Not semicolon, kids. Colon, colon. Oh, sorry, I forgot to use the cylinder, the class name, and then colon, colon, and set height, and then give it the same variable. And then right now you want your height. I'm going to call it H. And then just go ahead, define it. What is height? Assign it to H, semicolon. Again, I double check to make sure I did it correctly. Yes, because my green underline green is gone. Look at here. So I'm done with my setters or mutator. So far, so good. Still with me? Okay. So now I do have my getters or accessors to be defined with more detail. Let's do those getters now. Very similar to what I did for the setters. So in the getters, my data type is double. So I'm going to use the same double, not void anymore. So I say double. And then again, I have to use cylinder. Excuse me. I have to use cylinder as the class name. Let me just drink some hot water. I'm about to lose my voice. Okay. What do I put right after this? Yes. Colon, colon. Everyone do it. And then I have to use get because I'm looking at my accessor and I'm getting my radius first. And then do I need to use anything inside my parentheses? No, because it was empty. And then I have to say cons exactly as it was. And then I have to open curly bracket. And now it's time. It's a gather. So gather doesn't need any assignment in here. All I have to do is a return. I already set my radius. I'm talking about radius. I already set it to R. In here, all I need, kids, is just return. Return what? Return what you defined. Right in here, you define radius, then say radius. That's all you need. All good? That's the first getter. I do the same for get height. Quickly, double, again cylinder, again colon, colon, again get, and this time I'm getting height, empty parentheses, constant. Still with me, kids? Don't stay behind. And then return. This one is height. And then semicolon, and done. Now, I did this too, just I double check. Look at here, get radius, get height, both of them. They are okay. No more underline green. Make sense? What was your name? Hamza, are you following? Good. And do it on the computer, Hamza. Okay. Next. I'm done with that, but remember I still have volume. It's time to go and define volume. Volume also, it was double. The structure is exactly the same. Again, I'm gonna say cylinder. Again, the colon, colon. And still, since it is just extra function. It's not a setter, it's not a getter, it's just volume. Therefore, I don't need either of those. I simply say volume as it was. And then open parentheses. And of course, this one also was const. And now it's time. Volume is not already defined. I must define it. I need an equation. I'm expecting everyone to know like the math part of it, right? Probably you learned it in your math classes. How do you calculate volume for a cylinder? Who can answer this question? I already have it in here. You can see, but again, what you need, you have two methods. Either first, define volume in one line, say volume is assigned to, or you just simply say return. Of course, you need a return for that certain volume, but you can go ahead and define volume in here. That's much easier. Say volume assigned to, and then define it. How do you define it? Later return it. Return this volume. But first in here, define it. What is volume? Just go ahead and say volume is pi. If you do not want to use pi and you want to use the actual number, it's a constant number, 3 point something, you can do so. But if you want to use the pi, you must define it as a global variable somewhere. Therefore, I'm going to move, look at here. I'm going to move and go in here at the beginning of the code, right after the using namespace. I'm going to define a constant because I'm going to use it multiple times. So I define it as a const. Do it with me. Const double, it has decimal point, and I'm going to call it pi. And pi is 4 times arctan of, I'm going to give it the number in here. This one inside, I'm going to say 1.0 and then semicolon. Okay, this one is 4.0 times atan. Inside in here is going to be 1.0. This is my constant. And this is global. Means I can use it inside any other function. Make sense? So far, so good? Kids on the back of the class. Still with me? Did you know what I did? So right after that, I'll come back in here. Now I have that pi. I'm free to use it because I already defined it. It won't give me error anymore because I did it. So I'll go back here and inside the volume, I'll define it as just pi, but still I need more. Times what? POW I taught you in the previous course means standing for to the power of, and then all you need is your radius. And then it's going to be to the power of 2. So it's 20 and times, because you are calculating volume, times height. And semicolon. That's it, right? So your volume is calculated like this. This is one way to calculate your volume like this. But if you do it this way, again, you have to say double in order to avoid any error. Or you simply can have all of this just right in here and return it. Then you do not need to use double anymore. Make sense? So you've got two methods. One method to just include this part, the whole thing, this whole thing, just in here, or say volume double as volume as double, and then define it and return volume. So first, you good, kids. So who can remind us what was the second step of function for you? Anyway, I created some functions, right? After I create function, what's the next step for me? I define some function right in here. I define, as you can see, I defined like all of this function. Kids, the difference right now is I'm not, yeah, one more time. No, regularly when we create function, remember, we define a function as a step one. We define the prototype of it. We create prototype as a step two, and then we call it inside main. But I do not need prototype at this point. Why is that? Because it's already inside the public, right? And if you pay attention, you can see this is exactly the same format that we used to use for prototype. Make sense? That's why I do not need to redo it. It's considered right in here. And that's why I said class must be out of main. Now it's time to go inside main and do a step 3, which is going to be considered as function call. Inside main, first I have to create an object. Let's do it quickly. So I'm going to say, I call it cylinder. Can I use cylinder as data type right now? Who can tell me? Yes, I can, because cylinder is a class and anything like a struct. When I created a struct box last week, then I used box as my personal, or let's say customized data type. In here, cylinder is a class, so I can use it as data type. So I say cylinder and I give it a name, for example, object. Make sense so far? Then right after that, I'm going to declare all my variables. Why is that? Because anything I have inside this class, remember, radius and height in here. Also, I do have them, but they are private member. They are not accessible inside my main. Therefore, I must go ahead and redefine them inside the main. Okay? So now, I go ahead and say double. And then, since I created object, then I say object radius. You can use different name if you want to, or because this is private again. And then since I have two of them, I do the same for both of them. Object, the other one was height. And to make sure you can understand these are not the same thing, in here I use uppercase to give you that clarification. And then right after that, now it's time to just have some prompt for the user. So I would say this is not mandatory, but always it makes it more understandable. I want the user to now enter some information because I do not have that radius and height as an hard-coded inside the main. You can do so. That's also one option. Or another option is have a pop-up question for the user to enter numbers. Enter numbers or size or whatever you want to say. And then right after that, in here say, and I'm going to push this up a little, maximize to make sure everyone can see what I'm doing. Are you following? Is there anyone who's behind? Okay. At least at this step, everybody check right in here underneath the code. Do you have your green mark? If you do, then everything is correct. Then cin, remember for cin, your shift is the other way. What do you want? You created object radius and height. You want both two. So you can simply just copy this one, put it down. This is one of your cin. You can say object radius, again shift, object height. These are what you need in order to cin. And then finish it up right in here with semicolon. You're done with this step. It's time to start set the radius and height of the object. So right now you have the numbers. After you debug, then you give it the number. Then you need to get those numbers and then set them to the radius and height of that cylinder. Let's do that part. How do I do it? So since I called my object as a cylinder, I simply can say object. It is mandatory to define it as a function because I'm setting. Therefore, I say object dot set radius. Set radius, right? In here, I have my radius to be uppercase. Set radius. Set to what? Set it to object radius. Object radius. This is my first radius. This is my second radius. First radius in here, remember, it was lowercase. The one in here is uppercase. There was a reason for me to doing this to make sure you know these are different. And then I do the same for the height. For the sake of time, I'm going to copy this part for you because I have a lot for you to do in here. Then I'm going to display it. Display also, I'm going to display the radius. These are for the sake of time. All I need you to know, this is the first one. This first one, I set it to lowercase. This is the initial class. And then in here, set precision. If you want to use set precision, what would be the hash include in here? Somebody tell me. What? IO_manip. I need to address IO_manip. Otherwise, under set precision in here, I'm going to get error. So I'm going to display the result. Can I debug right now? Can I expect some result right now? No, not yet. Also, I don't have any error in here. But still, since I haven't called all other function, it might give me error. But still, it will give me at least some of the numbers in there. So next, I'm gonna, what do I want as cout? This is the time I'm gonna just, this part kids, all the cout, you know it. Therefore, I'm not gonna just type all of those. Otherwise, I won't be able to split the file during the class time, which is important for you to learn. So this part I copied from my existing solution. I already posted this solution on Avenue for you. So I simply cout the radius, the height, and volume. Volume is already defined what kind of mathematical expression I need to calculate. The volume under that volume function. We did it together. Now it's time to practice. Remember I said we can turn this one to a pointer. But at this point, let me give it a try for you. I'm going to debug. So far, I should be able to just get some information. I have cout. Everyone try to debug. I have some cout right inside in here. It should at least give me the radius and height. It's a little slow, but it's processing. Look at the processor. Everyone is getting the option to input information. It should right now ask me enter number. Yeah, it did finally. A little slow, but it did. I can give it two number, one for radius. I'm going to say 5.5. And then one for height. I'm going to say maybe 8. And then it's exactly giving me what I ask. Everybody should get exact same number as mine. Yes or not? I'm going to quickly come around. Also, I don't have much time left. You are not practicing. Yeah, good job. Anyone who's not practicing might be impacted during the lab. Are you practicing? What you missed last week, at least in here, you can compensate for. You do have, so in here, object is not defined. So first define your object at the beginning. That's why you get error. And this kid's in here, good job, good job. Then look at your equation for the volume. Probably, yeah. Because probably you have different, you have typo. So in here you said radius, look at the typo and see if you have your, where is your class? Look at inside the class. Inside the class, whatever you used in there, using there. And you didn't practice. And then if you are impacted during the lab and exam, then I know what to tell you. I just kick you out of the class. Okay. Kids, you got it? Good job. So let's go. Kids, now it's time. Thank you very much for following. It's going to really help you. It's not for me, it's for you. And I appreciate that you are helping yourself to really learn. Let's quickly now practice. Now everybody learned how to create class. Now it's time to learn how to turn it to pointer. So I'm going to, in order to turn it to pointer, I'm going to use cylinder, right? Cylinder is a class. I can use it as data. I'm going to define another variable. Let's say new object. Do it with me. I define another variable to practice how do I turn a class to pointer. It's good for you because one of your midterm question could be this one. And then I'm gonna say again, cylinder. Pointer means add asterisk. You already said new object. I'm gonna turn it to another variable. Maybe PTR standing for pointer. You can use any other thing. An object. OBJ. Now this is a pointer and I'm gonna assign it. I'm gonna assign it to null PTR. Who can tell me what was it? I explained this. What's null PTR? Somebody say it. Null PTR means what? Means address 0. Oh, sorry, I didn't see your hand. Means address 0. Means I'm sending it to address 0. Null is 0, right? Now, what is next? I'm gonna now store the address of this new object into my PTR object, pointer object. How do I do it? I simply say PTR. I do already have it. It should be PTR object. I'm gonna set them. So I use equal sign and then I use AND operator or what? Or address operator and then same name, which is new object. And now these two are in the same location, aren't they? These are both right now on the same location. Again, I'm gonna maximize. You may not see the whole thing, but at least this part is obvious to you. Following? Next, I'm gonna, kids, these are extra. I might not be able to finish the quiz. I'll activate it, you do it, okay? So, because I want you to really learn this stuff. Now I'm gonna set all my attributes. So I'm gonna just go ahead and say PTR object. This is my object. And I'm gonna say, do what for me in here? These are at like my pointer. So I'm gonna first do it for height or for radius, doesn't matter. For height, remember initially I had it to be user input. Now I'm gonna give it a number. So I'm gonna say 3. You may use any other number. And I do the same for the radius. Since it's a repeat, I copy and give it whatever. And make sure all your variables are the same. If you have lowercase, uppercase, do it exactly that way to avoid any error. And finally, I'm going to display and done. Then I will be able to split the file for you. So all I need is cout. Because I added pointer. Yes, how can I help you? This one? Yeah, this is just, in fact, I'm setting it into a certain hard-coded number inside. But since it is setter, I have to do it this way. This is the symbol for it. Yeah. Then cout, whatever you want. For example, I want the volume. I already have the volume equation. So volume. And I'm gonna now say, okay, how do you calculate the new volume for me? Calculate it from this PTR object. This is the new number, not the previous one. And then volume, I'm gonna write in here type volume and then your empty parentheses, and let me minimize. Out of empty parentheses, all you need is just \n, or if you want to use endl, do it the way I do, endl, either will work. And then I'm done. So I have return. I can also add system pause. I'm gonna go ahead and pause it. I have right in here. That's it. And get out of this semicolon. I believe if I expand this, it's gonna be much easier for you to see. See, I'm gonna just minimize. It's a bit lengthy, but I need everybody to see the green check mark and then give it another try. You already tried it. It was working for user input. Now one more time. Try in here. Give it another debug. I still have the Debugger open. This is the debugger. Enter numbers. Maybe I'm gonna give it 3.2 and 2.5. And then look at here. Now I'm having two volume. Yeah. I didn't use dynamic allocated memory. Dynamic allocated memory means using the keyword new. Did I use new in here? No, I never use keyword new in here. I created a new object. A new object in here is not dynamic allocated memory. It's just a name. It's a variable. As you see right in here, let me go back. It's a new object. It's a variable name under cylinder. That's a different story. That was a question? Okay. So if you use same number as mine, you can just function. Everyone got it? Still with me? Okay, good. So kids, I'm happy if you have that part. Simply means your life is much, much easier. As time, I'm going to close this one. Very last part, which is really important. Still, I keep repeating this step over and over until I see you are comfortable doing it on your own. Take a copy of this. So click somewhere, hit Control A, Control C, open a Word document for yourself because you need this for your backup in case you do it wrong. At least you have this part as your backup solution. Copy it for yourself somewhere. And then we are going to split it to multiple files as the last step. And we have only a few minutes to finish this. I'm going to run your quiz during your lab. Okay? This way I can give you more practice in here. This is beneficial for you. At the beginning or somewhere during the lab, I'll give you a quiz. Because if you learn this one, it's really valuable. How about that? So I'm going to keep a copy for me right in here, just in case I go wrong with any step. Still, I can come back and I can use that one. Now it's time to go create multiple file. How do I create multiple? Kids, this is important. This is completely new. So I'm gonna just move this one a little bit to show you how do I do it. Under your source, right in here, right click, like the way I did. Oh no, don't close, please. Okay, don't close. No, it's not closed. So right click, hit add, and then you're going to create class. Anytime you are going to create class, hit class. It will take some time. And then you have an option because we are creating class. You have an option to give it a name. Suppose I'm going to call it cylinder. This is important. You just give it a class name. By default, it will split it to a header file and .cpp file. Everyone following? Don't miss this one. And then hit OK. Okay. Do you know why? Because I already have cylinder in here. All I need, for example, I turn this one to lowercase. It shouldn't be the exact same name, okay? And then hit OK. Now it is generating it. Now, that's why I said keep a copy of that for your reference. Now, look at here. By default, one.cpp is created for me. Can you see it in here? And then another header file, right? Look at the board, right under the header file. Remember at the beginning I showed you nothing was in there. But now I do have that. The header file by default, if you look at here, you can see it. This is the header file. It's empty. And I have to fill it in. And now I want you to also double click on this new.cpp. Double click on this new, in this cylinder.cpp. Double click on it. And then if you double click on that one, you can see another file. Still it is empty, and I have to fill in those information from the one that we already created as a single .cpp. We are going to split that. Each portion of it is supposed to be under either of these two. That's important. You need to know what part should go under .cpp, what part under header file. That's the most important part of it, which many students go wrong with that. That's why at the beginning when I was creating the class, I left you this message right in here that this is going to be your implementation file. Look at here, and a specification. Right after that, anything under this is going to be your implementation. Now it's time to go fill in those spots. Everyone following me, kids? Do not lose this part. I'm just killing myself for you to not to miss what I am doing, okay? So under the cylinder.h, click on your header file. So now on, I'm going to call it header file. You know that I'm talking about the .h. Under this part, this I'm going to leave at the beginning for you one message. This is called my implementation file. Leave a message. This is, and remember it for the rest of the semester. This is implementation. So your header file, I'm going to even leave in here, .h. Let me minimize. This is going to be your implementation. So this is now important. What do you need to include under your implementation? There are two methods. One method is use #pragma once. This is correct if you use this given template. And then put down all those class information inside here. This is your implement. That's one method. Another method is just get rid of this because this is not always the best. Nowadays, there are better way of doing it. I'm going to ask you to go ahead and type #if and if. If and if. And then when you say #if and if, by default, it will generate and if for you. Create some room in here, then move this whole thing inside it. Oops. What happened? The screen share stopped. I think so. I'm going to go back to the screen. So since everything is just underneath in here. So then I'm going to, you need multiple computer in here. So move it to here, right? Move it into between. Now you need to complete these spots. So for the if and if, give it the exact same name, which is cylinder. But there should be a little bit more. So this is your .h. And then right after that, #define. Give it #define. And then again, you need to use the exact same name. I use cylinder.h, then say the same thing right in here. You see, gradually things are fixing. No more underlined red. Yes. Because this is not a header file. This is just a name. If I use .h, it becomes a header file, which we have to only use that in here. Then it causes error. Now, inside here, since I'm going to do some cleanup later, I'm going to use like the CMAS, and of course, iOS stream should be mandatory right in here. So what I do, instead of just doing a lot of information in here, since I already did it, I'll go here and I'll get all of those. So IO manip or whatever I have right in here, STD, I copy them from there, I bring them right inside here. Put them down right in here. So you copy from there, you paste in here. And then remember, anything I had in there, such as all these constants, and up to the end of the class. So copy everything in here up to the end of the class, beginning of main. Control C. You may want to even cut them if you want to. And then bring them in inside the header file. And one more time, I'm going to just clean up here to show you. Right in here, up to here, just paste all of those. So I cut them from the main file in here. Still main is there. And I paste them in .h. Still, you can see all of them are correct. Make sure at the end you have to have and if. If you are missing and if, let me minimize. This is all going to be considered as your .cpp. For your header file, I'm going to quickly do the .cpp file. So I have to just go ahead and get all the functions, not the main. So I'll move to the end. All of these functions, I cut them. I bring them to my .cpp file. Do this one. And still you see there is no error. And now, still I do have the initial one, which is the main. All I need in here, of course, I still need those IO manip and using namespace. Those steps are mandatory, which we always need them in any .cpp file. Using namespace. Std. Let me finish them. If I have time, I'll go back. So, and in here, remember now cylinder is not capital. Cylinder right now is just lowercase. But if I don't address the cylinder, one more thing that you need to learn. Now I'm under the actual main file, which we did initially. Therefore, right now, cylinder by itself is a header file. So I have to address it, otherwise it's not recognized. So then I have to say hash include. This is completely new, kids. Hash include, but I do use double quotation. And then what I'm gonna use in here, cylinder.h. Cylinder.h. Right? And cylinder.h, right now you can see my cylinder is known. Make sure this one is done properly. Then using namespace and then keep just everything as it is and you are done. So all we did is everything was inside one .cpp. I split it to a header file and a separate .cpp. Now if I run it, still I have to get the exact same result. If you did it correctly as I did, you will be able to give it two number as we did in the first step and calculate two different volume for you, because later I added one more step to calculate the volume as like in a new object. So now I'm going to do the same thing. So I'm going to give it 3.2 and maybe 5.1 and I hit, it should give me two volume. Hopefully everybody learned what I did. Of course, I'll post the recording because I'm pretty sure this is not going to be easy for you to learn everything as new with the first practice. It is mandatory to watch this recording at least one more time. At least one more time. Sure, I'll take your question. Let me finish. At least one more time before the lab. Watch the recording. Do not come back to me during the lab time and say, I don't understand anything. So I taught it. I ask you many times, practice with me, and I'm recording it and I'm posting the recording. Watch my recording, how I split it, how I created class, which part of the main question is under .cpp, which part. This is mandatory. And then you can do your lab. Otherwise, you cannot do your lab. Thank you very much for being here. I'll see you during the lab time. Anyone with question, I'm going to pause recording. Come see me and I'll help you with your questions. Let me just stop sharing. Yeah, come see me with any of your questions. Later also, you can post your question under this recording.